All right, everybody, here we are at 6.3, lesson 6.3 for geometry. Fun times. Okay, so oh my gosh, you guys are gonna not love this. Maybe you'll love it. This lesson is about proving that triangles are similar, okay? If you recall last semester, we proved that triangles were congruent, okay? We had 5 total ways to prove that triangles were congruent. We are going to learn new ways to prove that triangles are similar, okay? Similar, okay? So we're going to be able to decide if triangles are similar, and we are going to be able to solve problems using similar triangles, okay? We're going to use the following links to explore and follow directions, okay? We're going to go to this link, and we're going to see what happens when 2 triangles have proportional sides. Where are you? Okay. Come here. Is it this one? Okay. When 2 triangles have proportional sides, well, when the sides are proportional, the triangles are similar. Okay. Oh no, come back. Okay. I'm going to say the triangles are similar. Okay. What happens if 2 triangles have a pair of have 2 pairs of congruent angles? It means in 2 2 different triangles, 2 angles are congruent. Like this one is 60 and this one's 60, this one's 75 and this one's 75. Okay, so I'm going to watch these ratios here, my scale factor. Okay, I'm going to change that 75-degree angle. Well, it looks like the triangles stay similar. Okay, so if there are 2 angles, I'm going to say again, the triangles are similar. Okay. What happens when two triangles have 2 pairs of proportional sides and 1 pair of congruent included angles? The included angle. Okay. Okay. So I have that BC is proportional to DG, and then BA is proportional to DE, and I have that this included angle is the same, so the one between those 2 sides, okay? So if we change that angle, then the scale factor doesn't change. Well, what happens if we change the scale factor, the angle stays. But one way or the other, the triangles stay similar. I'm going to say again, the triangles are similar. Okay, so let's get on to some information here. Side, side, side postulate. If 2 triangles have 3 pairs of proportional sides, then the triangles are similar. Okay, you guys, again, it is not a congruent statement. It is not congruence, okay? So if I was going to look here at this, I'm going to super zoom here. I'm going to say that 5/10, the ratio of those 2 sides, is that the same as 9/18? And is that the same as 6/12? It is. Okay, all 3 sides are proportional. So this would be similar by the side postulate. Okay, those are the same values. 5/10 is 2, 1/2. 9/18 is 1/2, and 6/12 is 1/2. Okay, they are all the same proportion. Okay. Another way to say that 2 triangles are similar is my side angle side theorem. If 2 sides of one triangle are proportional to 2 sides in another triangle, and if their included angles are congruent, then the triangles are similar, okay? So in this example, I would say is 12 over 8, is that ratio the same as, hold on, did I do this right? Yes, okay, and it's 24 over 16. So if I reduce each of those proportions, for this 12 over 8 reduces to 3 over 2. 24 over 16 reduces to also 3 over 2. Okay, so those side lengths are proportional and the included angle is congruent. Okay, so that allows me to say that those two triangles are similar. Okay, similar. If two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. Okay, that is called the angle-angle similarity postulate. Okay, so let's go ahead and go through these examples 1 through 8. All right, we're going to try to zip through this quickly. Are the pair of triangles shown similar? If so, by what postulate or theorem? Okay, so let's see here. I'm going to check to see if these side lengths are proportional, okay? So I'm going to try, let's try like 16 over 12. Is that proportion the same as 12 over 9 and then 8 over 6? Are those all the same proportion? Well, what is that? They all reduce to 4 over 3. Okay, so those all three sides are proportional. So yes, they are similar by the side similarity. Okay. Okay, number 2. What do we have here? I have that one angle is 120 degrees. They told me that one is 40 degrees. I don't know angle M, but hey, I can figure it out. It's just 180 minus 120 minus 40. Okay, and so that gives me that is 20 degrees. Okay, so this one's 20, that one's 120. Yep, so these are similar by the angle-angle similarity postulate. Okay, so let's look at this next one, number 3. So let's look what I have here. I have that information about 2 different side lengths, and I have information about an angle. Okay, but hey, something that I'm noticing here is that I would prefer to know the angle like between. You know what I mean? Like I would rather know that angle, okay? Because this one is like not included, not the included angle, okay? And that's going to cause me problems. That actually limits what I can determine here. And I'm going to say like I'm going to say not enough information, okay? We can't actually tell here. Okay, so that causes me some problems. Okay, let's look at number 4. Okay, what do I have here? I have a couple of side lengths, and hey, one thing I do notice is I notice that I have vertical angles there, and I know that vertical angles are congruent, so I'm gonna go ahead and label that on there. Okay, so let's see if I do have proportional sides here. Okay. So I am going to see if 27, the ratio of 27 over 18 is the same. Okay, so 27 and 18 is the same as 36 over 24. Okay, so let's reduce this so I can tell what's going on. So what is this? 9 goes into there, 3 over 2. And 12 goes into there, 3 over 2. Okay, so I have a side angle side similarity statement here. I have that the two side lengths are proportional and the angle between is congruent. Okay, I'm going to have you guys go ahead and look at 5 through 8 and determine the information there. Okay, so for these 4 examples, we have angle, oops, I'm not sure what I put there. This is supposed to be angle, similarity. Then we have side angle, side similarity, side similarity, and then another angle, similarity. Okay, pause the video if you need some extra help there, or time there, okay? Okay, 9 and 10, find the values of the variable. All right, here we go. So first of all, I want to convince myself that these are proportional triangles, that they are similar, because otherwise there's no, information, there's not enough information. Okay, so here I can see that I have vertical angles there. So I know that these are similar because of angle, similarity, okay? So I'm going to set up my proportion. I'm going to say that x over its corresponding side, which is 6, not 7.5, okay? X and 6 are the corresponding sides. Do you see how they're between the these two congruent angles? That is between those two congruent angles, okay? So x over 6 is proportional to 5 over 7.5, okay? And I can solve that. 7.5x is equal to 30, and I'm going to divide 30 by 7.5 to solve for x, and I get that x is 4. Some of you guys are so smart and you can do that in your head. I can't. Okay. Let's look at number 10. Okay. So if AB, this big guy here is 10, I want to find F. Okay, so let's convince myself if I have similar triangles here. Well, I know that A is shared between these two different triangles, okay? And then I can see this bigger triangle here, okay? And they told me that these are parallel. Anytime they tell me something about parallel lines, I think about my alternate interior, corresponding, all that kind of stuff. And I remember that corresponding angles are congruent, okay? So I'm convinced that those are similar triangles by the angle similarity. Okay, so let's see what I can set up here. I'm going to say that F over its corresponding side on the other figure, which would be 10, the other triangle, that proportion is the same as 4, okay, because I'm going to go back to the little triangle over that corresponding side on the big triangle, okay? And that gives me a proportion. I'm going to get 7F is equal to 40, okay? And that gives me that F is 5.71, okay? Great. Okay, let's do one more and then have you guys try a few here. Okay, given that RST is similar to DCB, we're going to find S. Okay, find X. Okay, RS is proportional to CD. Okay, so I'm going to write that 11x minus 4 is proportional to CD, which is 50, okay? And I have my ST here, okay? That side length of 70 is proportional to CB, which is 60, okay? So let me write this out in letters. That might make more sense, okay? So my proportion is this, is that SR over CD, that ratio is equal to ST over CB. And then I'm going to plug in the values there. Okie dokie. If I can reduce, I will, because that is easier for me. And I'm going to cross multiply. And I am not going to forget to distribute, because that is a rookie mistake. And that would be incorrect. 50 times 7 is 350. Okay. Okay. I'm going to do this one a little bit of a different way, you guys. You could distribute here, but I'm going to go ahead and divide both sides by 6 first. Let's see, as long as it gives me like a nice number. If it gives me, nope, actually I'm not going to do that. It gave me a wonky number. I'm going to save that for later. I am going to distribute. Okay, minus 24 is equal to 350. Okay, I'm going to add 24 to both sides. Okay, 350 minus 24 is 374. 66x is equal to 374. And I'm going to divide both sides by 66. And that gives me that x is 5.67. Okay. All right, you guys know the drill. Go ahead and give a try for number 12. Okay, for number 12, pause again if you need to look over it, but I go ahead and get B is 12. Okay, I'm going to have you guys go ahead and try numbers 13 and 14 as well. Okay, here are the solutions for x and y for number 13, and then just x for number 14. I didn't miss a variable in number 13, did I? I think it was just x and y. Okay, so pause and revisit this if you need a little bit more clarification. Okay. All right, last problem to conclude 6.3. Okay, to determine the width of a river, Naomi finds a willow tree, and here's the willow tree, and a maple tree directly across from each other on opposite shores. Using a third tree on the shoreline, it must be that sumac, Naomi plants 2 stakes, A and B, and measures the distance shown. Okay, so she measures 8.4 meters and 9.3 meters, and then the 24 meters. Okay, find the width of the river using information that Naomi found. Okay, so she created similar triangles here. Okay, so what we can see here is I'm going to make this width of the river x, because that's what we're trying to figure out. Okay, so I'm going to say x over 8.4 is equal to, I'm going to go back to the big triangle, which is 24 over 9.3. And I can solve that by cross multiplying. 8.4 times that one I can't do. Clear. 8.4 times 24 is 201.6, and I'm going to divide that by 9.3. And I get that the river is 21.7 meters across. Cool. Okay, that concludes 6.3. Be sure to follow up any questions with your teacher.